In this video, we describe instructional activities that we call partitioning activities. Partitioning activities complement the patterning activities that we have described in finger patterns, dot patterns, and the singleton frame. In the patterning activities, children use grouping strategies to figure out the total. They build up the quantity by combining smaller quantities. Partitioning, on the other hand, involves breaking down a quantity into parts. For example, you can partition 7 by splitting it up into 4 and 3. We use the label partitioning because it describes the activity of the child, whether it's physical or mental, that results in the partition. Children's understanding of partitioning numbers develops in tandem with patterning. In this video, we're going to describe several activities that have partitioning as their express purpose. In each case, children start with a specified quantity, and their purpose is to break it into smaller quantities. The purpose of these activities is for children to begin to develop partitions of the numbers of 10, and the idea that the partitions of a number are related to the partitions that make up another number. For example, the partitions of 7 can be thought of in relationship to the partitions of 6. Here we're going to describe 3 different activities that have partitioning as their express purpose. They're one that we call the monkeys in the trees activity, an activity we call the double-decker bus, and an activity that we call all the ways. In each case, the children are going to start with a specified quantity, and their task is going to be to partition it or break it into smaller parts. As we've said already, these instructional activities are intended for use along with and intermingled with the patterning activities. The first activity is the one that we call monkeys in the trees. This title is based on the scenario that underlies the activity. We're going to give an example of the activity, describe its purpose, and then finally talk about what it is that children do. This is a whole class visual activity. The teacher uses the provided picture to show 2 trees and some of the monkeys. The picture that we've shown here shows 10 monkeys, so the task can be about any number 10 and below. The teacher simply shows the number she wants the task to be about for that lesson. For example, if the teacher wants the task to be about partitioning the number 6, she shows 6 monkeys. It's easy to do. Just cover up 4 monkeys so only 6 are visible. Now, to explain this activity, we're going to use the example of 6. So the teacher shows the picture with 6 monkeys. First of all, the teacher has to explain the scenario. The scenario is of monkeys that like to play in the trees. There are 2 trees the monkeys can play in, a big tree and a little tree. Now, it's important to emphasize that all of the monkeys are in one tree or in the other. None of them are on the ground. The question is, how many monkeys might there be in the big tree and how many in the little tree? And the children's task is to come up with different ways to answer that question. The teacher's going to record the children's responses in some way. Now, one useful way to do it is a table, and we're going to illustrate that as we talk through this example. One of the features of this activity is that the visual material is not flashed, but it's left visible for the children to see throughout. Another feature is that unlike dot pattern and 10-frame activities, where the teacher uses chips that can be moved around during the discussion to clarify and elaborate what children have said, here the pictures of the monkeys are fixed. The teacher can't move the monkeys in the trees. This feature is deliberate because it requires children to reason more abstractly about the visual material. Children can only think about which monkeys the trees are in, but they can't actually see the monkeys in the trees. So what do children do? Well, typically, the teacher is going to use this activity after children have worked with patterning activities for several weeks. And therefore, children already have started to develop notions of partitioning numbers. As a result, a number of children will offer ways the monkeys will be in the trees based on their already developed understandings. At the same time, other children are going to use their finger patterns to generate partitions. So let's look at what Katrina did. She puts up 4 fingers on one hand while counting 1, 2, 3, 4, and she continues counting 5, 6 while putting up fingers on the other hand. Katrina then looks at her hands to figure out, oh, there can be 4 monkeys in the big tree and 2 in the little tree. Now, in some activities, the focus is on discussing how the children made the 6, but that's not the focus here. The focus here is for the class to reflect on the way 6 can be partitioned. So to this end, the teacher might say something like, Katrina said there are 4 in the big tree and 2 in the little tree, and then she might draw a table and record the result. The teacher might then continue by saying something like this. Is that 6? Did anybody else think about 4 in the big tree and 2 in the little tree? Another child in this class, Sam, might just know a finger pattern for 6 and use that as a way to generate monkeys. He might just hold up 3 and 3 and say, oh, I know that 3 and 3 is 6. The teacher might say, how many people agree with Sam that 3 and 3 will be 6? That's a double, and record his result. Other children by now already just know some combinations that make 6. For example, James might say, I know 5 and 1 make 6, so put 5 in the big tree and 1 in the little tree. Again, she might attempt to draw others in the conversation. She might say something like, Morgan, do you agree with James? Will 5 and 1 more make 6? As these examples show, children at widely differing number conceptions can participate meaningfully. Katrina counted. Sam already had a finger pattern for 6. And James just knew a combination. An underlying principle of our inquiry approach to math instruction is that all children should have personally meaningful ways to participate in every task posed. One important mathematical principle inevitably comes up in the discussion of this activity, and it's this, that you can just change the order of the monkeys. For example, Thomas might say, well, just switch them around. Put 2 in the big tree and 4 in the little tree. Children often express amusement at this discovery, kind of indicating that they realize that it doesn't just apply to 2 and 4, but to any pair of numbers. For example, once one child suggested switching a pair of numbers around, others often make similar suggestions, such as, well, put 5 in the little tree and 1 in the big tree. As this example illustrates, important mathematical ways of reasoning emerge from apparently simple instructional tasks. Notice, too, that in this case, the teacher isn't the one that introduced the idea to the students. What happened was that the students became aware of it on their own, representing an important advance in their understanding of number relationships. It's also important to notice that this discovery is not going to be made by all students at the same time, but the teacher can call attention to this issue when it arises. Maybe she can ask the class, Thomas said that if you know 4 are in the big tree and 2 in the small tree, we can also have 2 in the big tree and 4 in the small tree. What do you understand about what Thomas is saying? In this way, students that did not make sense of what Thomas said initially have an opportunity to reflect on it further. This introductory activity also reveals that not all students know that if, for example, 4 and 2 is given, that 4 and 3 or 4 and any other number than 2 won't give a total of 6 monkeys. For example, Carly might offer a solution of 4 in the big tree and 3 in the little tree. In keeping with our approach that the teacher does not evaluate every child's comments as correct or incorrect, we recommend that in this case, the teacher simply records the incorrect answer in the same way as she recorded the correct answers, and she might even repeat what Carly said. By this time, children are beginning to understand that it's their responsibility to ask questions or raise challenges if they disagree with what someone has offered. So in the case of 4 and 3, somebody will disagree. Somebody might say, well, because 4 and 3 is 7 and not 6. Or another child might say, well, 4 and 2 is 6, and 4 and 3 can't also be 6 because it's 1 more. This argument is quite sophisticated, and therefore it's worth being acknowledged by the teacher and reiterated. We've talked about how the teacher initiates the monkeys in the trees activity, various ways children might generate partitions, and important mathematical principles that typically come up in the discussion. Another important issue arises as the teacher continues to ask who has another way, even after she knows all of the possible ways have been given. In doing so, the teacher shifts the children's mental activity from generating a single partition to the number to trying to think about all of the partitions as a whole, the set of partitions. In our experience, most children continue to try to come up with more ways, but usually somebody will suggest there are no more ways, that all of the ways have already been given. So now the question becomes, well, how do we know we have all the ways? How can we be sure? This question is of a completely different nature and requires a completely different type of cognitive activity from just generating a partition. This question is a higher level question and one that we would expect not all children can answer at this stage. In fact, typically the majority of the children decide there are no more ways just because they can't think of any others. One or two children may attempt to explain other ways to reason about how they know for sure there are no more ways. However, often this question remains unresolved for the class, and we urge teachers to not provide a resolution to this question themselves, but rather wait for it to emerge from the students. The rationale for this suggestion is that for reasoning to make sense to students, it must arise from their own conceptual understanding. Remember that the goal of this activity, as with all of our inquiry activities, is not that students say and do things that others and repeat what others have said, but that they say and do things that make sense to them. You'll notice, for example, that the numbers shown in the table were recorded in the order in which they were given by the class. The teacher made no attempt to put them in any specific order or to indicate how many combinations there are. You'll notice even that when she drew the table, she didn't draw in exactly the number of lines needed for a complete set of combinations. These actions are deliberate. This activity is not about being able to complete an ordered set of numbers that combine to make 6 quickly and easily. It could be very tempting for the teacher to put the numbers in order, but we found that when teachers do so, students often learn to replicate number combinations kind of mindlessly, and they're no longer thinking about the number relationships. That means this activity is no longer useful as a learning activity. Just to emphasize again, we do not intend that after engaging in this activity, children will just know all of the partitions of the number used, in this case 6, or even how many partitions there are. This is in sharp contrast to many traditional instructional activities that do have that as a goal. The monkeys in the trees activity is only one of many that lead to children's development of partitions. In other words, we do not intend that this activity be repeated over and over again till children can list all partitions easily. It might be used only a few times, and then with only a few of the numbers, up to 10. We've already noted that the question of how can we be sure we have all the ways is a higher level question than the question of generating a partition of a number. It involves reasoning and thinking about the entire set of partitions. The teacher might decide to pose similar higher level questions such as, will there be more ways or fewer ways if there were only 3 monkeys playing in the trees? Or will there be more ways or fewer ways if there are 10 monkeys playing in the trees? These questions are less complex than the question about how many partitions there are of a particular number, so most students will have a way to begin to think about these numbers. We've used the task with 6 monkeys to illustrate the features of the task, how it might be posed, how children engage, productive teacher actions, and how the task can lead to higher level questions and higher level reasoning. Another way the teacher can promote children's advancement in partitioning is to be deliberate in posing tasks in sequence. For example, if the teacher poses the task, using 7 monkeys or 5 monkeys after the task with 6 monkeys, it's likely that at least some children will relate the partitions for 7 or for 5 to the partitions for 6. For example, a child might say that sits for 6 monkeys, there could be 3 in each tree. For 7 monkeys, there could be 3 in one tree or 4 in the other. Such apparently simple teacher moves have huge implications for children's learning. For this reason, careful teacher planning is essential. Well, we've said that another partitioning activity is one that we call the double-decker bus. This is a lot like the monkeys and the trees activity, but instead it uses the scenario of a double-decker bus. The teacher indicates the number of people on the bus, and the children's task is to figure out how many people might be sitting on the upper deck and how many might be sitting on the lower deck. In this activity, a picture of a double-decker bus is shown, but there aren't any images that represent people. So in this sense, the activity is more abstract than the monkeys activity. It can easily be used as a whole class activity where the teacher records the partitions children suggest, or it could be used for partner or individual work. In that case, the task is for the pair of children or the individual child to write down as many ways as they can think of for the people to be on the bus. A culminating discussion of what they've written down is important because through the discussion, children have a way to hear what partitions that other children have generated, but also the way in which they've thought about listing them. The teacher might choose to use this activity only once or twice, or maybe not even at all. Its primary purpose is as a link to the instructional sequence structuring numbers. That sequence is based on the scenario of a double-decker bus. Teachers that choose not to use this activity here can easily introduce the double-decker bus scenario later on when it's needed. Here you see samples of students' work for an adaptation of the double-decker bus task that was used early in the 2nd grade year. Students worked with a partner to complete the tasks which were discussed in the whole class. Of the 5 tasks on the page, 4 were prescribed. The 5th task, shown in the middle of the page, was left blank so that students could choose the number they wanted to use. Children in this class chose the numbers 8, 11, 20, and 5. Both examples here have 8 as the choice. These samples show the various ways children thought about partitioning a number. Some were somewhat systematic. Some were more random. Some included errors. Notice, for example, in the sample page on the left, that the partitions for 9 included 5 and 3 and 3 and 5, immediately followed by 5 and 4 and 4 and 5, and also 3 and 6. And on this same sample page, partitions of 8 included 4 and 5, 5 and 4, 5 and 3, and 3 and 5. None of the solutions included all of the partitions. By contrast, the sample page on the right has no errors, and most of the partitions for each number are given. I just want to reiterate that this page was used in early 2nd grade. I wouldn't advocate using this page in 1st grade. Rather, if you're going to use the double-decker bus task in 1st grade, provide only a single number for students to work on at a time. The last activity in this group is one we call All the Ways. This activity grew out of observing students complete a typical textbook task that was really unproductive. So we're going to show you what the textbook task was. It's out of a workbook, and it's about the number 10. Workbooks like this often would have a separate page for 8, 9, 7, 6. Here's what the task was. The page is titled 11 Ways to Make 10. And the students were instructed to cut out the numbers on the bottom and then paste them into the blanks so that they could make 10. Well, besides the fact that cutting and gluing takes a lot of time for 1st graders, and it takes a lot of time away from meaningful mathematical activity, even the title, 11 Ways to Make 10, is questionable. We have seen children successfully complete a page like this and yet not be able to generate partitions on their own in a non-structured setting. It's experience with tasks such as this one that led us to pose a more open-ended task, a task at which children would participate at their own level. Write all the ways that you can think of to make some number. In this case, the example we've chosen is 8. Each child is given a piece of paper and just simply told, write all the ways that you can think of to make 8. Experience shows that some children will write number sentences. Some will make a chart with columns. You can see where that comes from. That comes from thinking about the monkeys activity. Some children generate almost all possible combinations using 2 numbers. Some may even have the combinations listed systematically or somewhat systematically. Some will generate only 1 or 2 combinations. Other students will go on and use more than one sum and some will use subtraction as well. When this is used in a classroom, children that complete the task quickly can be given another number to use while others are finishing up their first one. You'll notice the similarity of this task to the double-deckers bus task. However, there are important differences. One difference is here the task is posed without a context. The other difference is that the task here is so much more open-ended. The double-decker bus activity asks students how many people might be on the upper deck and on the lower deck. So that limits students to coming up with 2 numbers that sum to 10. Here there are no constraints at all. A lot of teachers that we've worked with have used this activity as an assessment activity. Through this activity, they can gauge the child's ability to generate partitions. How many can they generate? How accurate are they? Are they listed systematically? When this is used as an assessment tool, we recommend that it's not discussed as a class discussion. Instead, the teacher can send the children's work home for parents to see or maybe post it on the bulletin board. How to use the partitioning activities, when to use them. In this video, we've described 3 instructional activities that are specifically designed to promote partitioning. Monkeys in the trees, double-decker bus, and all the ways. Each one involves breaking a number apart, that is, partitioning it into 1 or more smaller numbers. As we've already said, children begin partitioning concepts when they engage in patterning, such as finger patterns, dot patterns, and the single 10 frame. With this in mind, we recommend that teachers begin to use the partitioning activities around the 2nd or 3rd week of the school year, while they are still making heavy use of patterning activities. It's important to remember that all of these activities have as their purpose promoting conceptual development of children's world of number. The purpose is not that children learn to do these activities or that they get good at them. Teachers that use these activities over and over again are missing the intention. The intention is that through engaging in these activities, along with the pattern activities, children begin to develop a conceptual foundation for reasoning about quantity. For that reason, we recommend using these activities only several times, as we've discussed earlier and is listed here. We encourage teachers to keep moving forward. We include a suggested timeline here for your reference. We show the patterning activities, finger patterns, dot patterns, the single 10 frame, the partitioning activities, and there will be another video that describes additional activity. The dots following along in each line indicate when these might be used productively. Now, I would like to make one additional comment about the suggested timeline. It's shown for weeks 1 through 6. Many teachers actually extend this to the first 9 weeks of the school year by using these activities 4 days a week and then using a 5th day for other important concepts like the forward and backward number word sequence, counting by 2s, 5s, and 10s, and the important area of geometry.